My plan for the next hour is to try to set up the robot template code, but partially to walk through what it looks like when we convert a old project into 2023, so you can see kind of what that process looks like, and you can see some of the changes that have to happen, because there may be some stuff that we pull from old stuff, and you have to like move code around sometimes. So just kind of giving you an idea what that looks like, and this also kind of, again, reestablishes some of the framework that we're going to be using to build up the 2023 software. So I'm going to open a new folder. So whenever you download something from GitHub, most of the time the code's in a folder. So there's a bunch of stuff. Like I have a bunch on here. Some of these are other teams. Some of these are projects that we have. But almost always they have their own project folder. One of them is the SpectrumRobotTemplate that we were working on for 2022. Like we didn't actually base our 2022 robot off it. This is new, but we haven't moved it to 2023 yet. So I'm going to open it up in VS Code 2023. Sure, that's for other stuff. Okay. So once it gets open in here, it says it's not compatible. Would you like to import this into 2023 beta? And so I'm going to say yes. And so it brings up the importer dialog. There's a couple annoying things about this in that it won't just update directly in the same folder. It creates a whole new folder, which is understandable. It doesn't want to erase stuff that worked, but we actually do want to put it on top. I also need to open GitHub real fast. So I'm going to double check that our robot template somewhere here. Okay. Sure, I'll post this up as the last 2022 update, something like that. Make sure that's committed, and then I'll also I'm going to create the tag to tell that this is 2022. I also might pull a branch in a second too to leave a 2022 branch in case we need it for some reason. We probably don't for this, but it's still useful. Oh, well, I messed up. So there was some stuff that was on the server that I didn't pull down yet. So I'm going to figure out what the conflict is right now. Actually, we can pull robot telemetry. We're just going to use the one from origin main because that was stuff I was working on later, so I know that that's fine. So it'll commit and everything's good there. So you have to choose, sometimes if there's merge conflicts, you have to choose which one to use. So most of the time, I guess it kind of depends, but sometimes if it's something that you weren't editing, if it's a file that you weren't messing with, you can just choose to use the one that's ahead of it, because sometimes a couple minor things might change just when you're working. Most of the time, it's not a big deal. Sometimes it is, and you can pull those in other ways. Okay, so yeah, so it has it up to 2022 now. And I'm going to go ahead and push that. And then I'm also going to I'm going to make a new branch for 2022, so if we ever need to come back to it, we can come back to the 2022 branch easily if we need to use it. I need to push that. Did that work? Okay, I need to publish branch, but it doesn't want me to. Oh, because I can't publish the branch without a change. That makes it weirder. What can we do? We can do that really quick. Some of the stuff we don't care about. I'll just delete a comment and it's fine. Okay, so then that should let me commit that. There's probably a better way to do that than what I did, but this works. Okay, and now it still cannot publish branch detached head. Okay, well this is sometimes where GitHub messes up, and I somehow messed up. So I'm gonna go ahead and just error branch heads 22 not found. Well, of course, why would it be found? That's very confusing. All right, well, we'll figure that out later. I'm back on main, and that's fine. Okay, I'm gonna put it back to, but I want to move the tag. I can do it on GitHub, I think. Okay, so some of this I should have planned out before, but that's fine. Pull it up into this, and we can figure out what we're doing wrong. GitHub stuff is always going to be a little mess. This is probably the thing that's going to cause our most issues as we start figuring out how to work with multiple people together on our commits and figuring out how some of this is going to work the way we want it to. Because it's a little tricky until we, because I'm not, like I said, I don't program for a living, so I've done it enough and I know what I'm doing. But there's a lot of times where there's Git stuff where it's easier to do some stuff from the command line. I try not to do too much of it that way because it gets really confusing. Not that this isn't confusing, because it is, but it gets worse when we end up too far off. So yeah, so it only has main, which is fine. But my computer now has this other branch that I don't want, that it won't let me get rid of for some reason. So we'll figure that out. It doesn't affect anything else except for this computer. But there's no easy way to change the tag on the other commit either. Okay. Okay, that's fine. We'll deal with that later if we need to. Okay, so we're gonna make, back to what we were originally doing and what actually is important here. So we're gonna make this, we're gonna import it from 2022 into 2023. So it asks to make, so most of this will auto-populate, so it says where the build.gradle file is. For your new project, most of the time on any of the computers, especially on any of the team computers, the base folder for anytime we're checking anything out of GitHub or any of our projects should just be C:/GitHub. I recommend you do that too. It's the easiest way to keep all the projects in the same place and we know where they are. It doesn't have to be. If like you want to use it in a documents folder on your PC, or if you have something set up differently, it's fine. But if we keep it there, it just standardizes it across our team stuff and makes it easier. Like I said, it does have to have its own folder, so I'm going to make a new folder first, and then we're going to move it over into the old one so we can keep it all in the same repository. So it's going to create a new folder. Team number, all of our testing stuff gets built as 3847. At some point, when we start doing Photon stuff, we sometimes have to change the team number to 8515, but we'll talk how to do that. But anytime we build stuff just generically, it stays 3847. And then we'll put stuff to 8515 when we need to. This is a desktop only, or you can enable desktop support, which lets us simulate. So anytime we make a new project, anytime we're making anything, we always check this box so we can run the simulator. I kind of wish this was done by default, but it's not set up that way at the moment. And then if it happens to be a Romy project that we're importing, we import it as a Romy project. This is not, so we don't need to. So we're going to go ahead and do import project. It's going to create that project, and we're going to let it import into the same window is fine. And we can actually see, here that we now have a SpectrumRobotTemplate 2023 and the SpectrumRobotTemplate. So I'm going to make sure that we're going to double check that this can build, so it automatically starts doing the build when you open it. It has some build failed, which is kind of the point of this video, is to start going through and learn how to fix some of these things. So on the import, a lot of times you get things that don't work because they've changed the library. So now we have to know how to fix those problems. So once you get the build failed, the first thing you do is you scroll back up and you start seeing what happened and what the errors are. So I'm going to go up to the top and find the first one. And we can start seeing where things went wrong. So the first thing, it has some things where we pulled from Spectrum library. And it doesn't, the imports aren't existing the way they think it's supposed to. Some of that might be in how we're importing that. So Spectrum library is another package that we have that's been updated in 2023, so it should be importing correctly, but it doesn't mean that it is. Let's figure out where that actually happened. So this is in the build.gradle file, and we should have, oh, because it made a new build.gradle file when we imported, and we don't have the old one. So I'm going to go pull the stuff we need from the old build.gradle file. So I'm just going to go ahead and let it open up here. And so we have some things that we add to all of our projects to make them run a little bit easier for us. Most of the time you don't have to touch this. You should like never be touching the build.gradle file unless you're talking to me about something or figuring out what we're fixing. Most of the time this should already be all handled in the back end, but it is useful to know what's different about stuff that we do on our projects compared to what may be happening if you just open up a normal template and you're like, why isn't this doing something? It's because our code's running a little bit different. One of those things is called Spotless, which helps auto format a bunch of our, all of our code for us. So it handles like, when you actually go to build, it'll auto indent everything. It fixes some comment stuff. It fixes some other things for us. And so it has this whole configuration set up right here for what the Spotless configuration does. Oh, I need to grab the last thing. And so every time it builds, it will run Spotless on all of the code and clean it all up. It cleans up all the imports. It does a bunch of auto stuff for us so that we're all of the files kind of look the same no matter who's writing the code. And we don't have to worry too much about it all looking different depending on who's authoring it. It keeps us a lot cleaner and working together. So that's one of the things that goes in the build.gradle file. The other part of it is the part where we tell it how to actually find the Spectrum library. So if it says frc.spectrumlib can't be found, it's because it's not in the build.gradle file normally, or you don't have an internet connection or something. So we're going to go ahead and move this over, and we can put it basically in the same spot. So under include desktop support, we're going to throw that part in there. And then also we have our implementation for, we have the include for the SpectrumLib in the project. So we're going to add that into our dependencies. So this is something it requires to be able to use. So the other list up here are it actually pulling the dependencies for the WPI lib and stuff like that we also need in here. And one of the things that we now need is SpectrumLib as well. I'm trying to think if there's anything else that I know we have to pull out of this. I don't think so. I think most of that is all the same. Unless we pulled all of that. I think the rest of the build.gradle file is everything else. So this is just how it says what happens when we go to simulate, when we actually tell it to deploy, how to actually do that. So some of those things change when we change team number. It auto changes some things. But yeah, so that should be most everything we need. Okay, so if I save this, and then if I read build the code, so if I hit build robot code now, it should have fewer errors. There probably should still be a few. All right, so now it has fewer errors. And so now it says, could not resolve all runtime, could not find comp, path planner, Java. So, okay, so this is because it's missing the vendor deps. So the other part of the library, so our own library doesn't get installed as a vendor dep, it gets installed directly in the build.gradle file like I just did. And again, now that that's done, we shouldn't have to touch that again. The other things that we have to install are the stuff that we use that aren't in the WPI lib directly. So there are things that the vendors, like Vex and Rev, or CTRE and Rev, and Path Planner and some other people who write stuff, they can put out libraries, and the vendor package manager thing that they have lets us add those in. So I'm going to go ahead and open I'm going to make a new window, and then I'm going to open the Romy test project so we can pull those out really fast. There's different ways to get them. Let me actually show the default way real fast. So if I go to WPI lib vendors, this page in the docs has has all the information about how this works, what the libraries are, and also has the most of the vendor links to actually install them. These are all the 2022 ones because these aren't in beta. These aren't the beta ones yet. So for the beta ones, I'm going to do that by pulling it out of our Romy 2023 code. So I'm going to open recent, open in here, and then we can go ahead and look at what the vendor depths are. So yeah, so these have a few more that we don't have yet. So the one that we just saw the error for was that it can't find Path Planner. So that's in here. So I'm going to pull the Path Planner. Oh, is that actually even the... I don't know if that's the right 2023 one. I think it is, but we're going to double check real fast. Path Planner. So for Path Planner, that's something that gets released on Chief Delphi. And so we have, we can see what the pre-release looks like with Path Planner. Oh, install Path Planner lib. There we go. So yeah, so it looks like, so it looks like the 2023 library is already at that same link. So that's easy enough. And that we verified that, we know we can use it. So then to install a vendor library, a lot of the times, pretty much everything for like the specific WPI lib stuff all gets used in the red button up here, the W button. And then we can do manage vendor libraries or type vendor, whatever it is, to get there. We're going to install a new library online, and we're just going to paste in that long link to the .json file that has the information that's needed for it to pull down that library. So I'm going to go ahead and hit enter. It's recommended to do a build after, which is fine. We see that this got added over here. And so now we still build failed, and we can figure out why. So now it's asking, it couldn't find the revlib Java files either. So I'm going to pull those as well, so we can normally find those in here. I think this one, so this one is still pulling the 2022 revlib. And so we have 2023 revlib on our stuff in here. Oop, not that one. Where is that? That might be... That's in here. Okay. So now this is the revlib beta release is at a different URL. So I'm going to go ahead and make sure we install the correct one. We may have to update it in our Romy file too, but we don't really use it there, so it's not as big of a deal. Manage vendor libraries, install new library again. Resulted in an error. Okay, apparently I copied the wrong thing. What happened? Oh, because I didn't actually click the link and pull the correct. Yeah, it needs to end in .json, so that was my mistake. Let's try that again. Manage vendor libraries, install new library. Yes. Okay, so now we have reblib, and now it's building again, and we'll see if that one works. I think it's still going to need CTRE, but I'm not sure. If it doesn't need CTRE, we'll probably still add it anyway. Okay, so yeah, so it does end up being able to be built without that, but I'm going to go ahead and get the CTRE one as well. And so this is the latest Phoenix 5 library. And we'll make sure this is installed because we want to be able to use this template to start our code for whatever robot we're starting it for. So if we're starting it for like a prototype robot, if we're starting it for 8510 or for 3847 2022 rewrite, whatever we're starting it for, we want this to basically be the standard base package to be able to copy over and just start using. So I'm going to go ahead and install that as well and get all of most of our vendor libraries set up. I think that's most of the ones we end up using the most. I think that's all the ones that are in Romy. Sometimes we get a few more added, but I don't think they're required. So now this is building already, so that's useful. So we're pretty much, we're already at the point where this works now. There's not a lot of other stuff we have to do for this to work, but we can look at what's in the default stuff. So we kind of already saw this with the Romy code. We have our default robot file, which has the setup to get us a config file, the robot config, our pilot gamepad, telemetry, telemetry being all the stuff that is data sent back to our laptop console, so that our drive team can see it during the match, or that we can debug stuff, all of that that's going on back to the laptop. It has that same sort of setup that we're using, where we're initializing subsystems and then calling their default commands, or their setup default command from each one of them. So that would be the same thing we do for all of it. So if we make a new subsystem, if we have an intake or something, we would have an intake built into this. We kind of follow the same pattern, do intake.setup default command, and that should all be the way it works for everything. And we'll look at what that means in just a second when we start going through adding things in for programming on Flash here in just a second. Yeah, so a lot of this is all just kind of the default template stuff. We tried to comment a decent amount of it. Some of it I need to clean up some comments because they were kind of the ones that were included and probably aren't needed. Probably some others that need to get added. We'll probably try to make this better as we go. And hopefully this stays together to where we're making a new version in 2024 that adds a little bit more functionality, as much as we can to keep our structure and keep everything organized where we need it to be. Okay, since this is already building, I'm going to double check that it runs at least when I go to simulate robot. It shouldn't really do anything. There's nothing for it to do. But I just want to make sure there's no like main runtime errors, which show up when it actually runs and not just when it builds. So it looks like it did what I expected. Pilot gamepad not found. Yeah, so it couldn't open the persistence file because it didn't exist yet, but it should exist now. Yeah, so everything else should be good the way we expected. There aren't any devices. This is just running the code, but there's nothing there to output or do anything because nothing's set up yet. So that's fine. Okay, so with all of that, we now have our 2023 software ready to go, but we need to get it on GitHub in the same project. So I'm going to go ahead and actually copy over, what am I going to do? I'm going to actually delete the gitignore file real fast, and I'm going to copy over the rest of it into the robot template. What did I not want in here? So we want to delete out most of this. I'm going to add back in the new path planner here in just a second. And I'm going to leave 6328 network alerts because that's what we get added to our shuffleboards, that we can run the little alert plugin that they have. I'm going to show how that works in just a little bit too. So I'm going to delete some things out of here, and that's all going to get replaced. All right, so that all gets pasted back in. So we have a copy of all of those. I'm going to, yeah, so we close that one. What do I need? Oh, I need to pull the path planner. Different command groups on those. So I'm going to install Path Planner real fast into that folder. So then whenever we copy it, we'll have the current version. This will get updated as we go through and add stuff. We're at the bottom. Let me hold the top. Maybe. There we go. Okay, so we have Path Planner 23. There should be a zip file. Go ahead and put that into here. So this way it always, whenever we commit, we can pull down the same version so we know we're all working on the same versions of Path Planner every time. So now it has a ton of changes in here because we, oh, you know what I did that was bad? Let me pull that from, I deleted the gitignore file out of here, which is important. Let me go re-download that because I made a mistake. Where do I have that? I don't have that anywhere. Oh, I'm on the wrong thing. That's why I need to not have that up. SpectrumRobotTemplate, git ignore. So this helps us, the gitignore file is what tells it certain files not to submit to Git ever. So anything that has these like file extensions, if there's a .zip inside the folder, it won't commit that to GitHub. Same with some of the other things. I don't know if this actually has all of our stuff. Does this have everything we need? Build output. Might want to pull our one from, actually might want to pull our one from Infrared 2022. I think that one has more stuff in it. Oh, no, maybe not. Okay. Okay, good enough. Yeah. All right, so I'm just going to download this to that place. Sure, and then I'm going to rename it. All right, so it has to be renamed .gitignore. Yes. All right, and that should change some of what it has to commit. Yes, now it's only committing 54 changes, which makes a lot more sense. So some of the things were files that already existed that are just getting updated. Some of them are new or getting deleted. But this is now our update to 2023. All right, so that gets committed to main. And we can push to origin. So now we have a functional robot template for 2023. It exists on our GitHub. We can see it out here now. Yeah, so it has the update to 2023 on here. And so when we download this, we now have, we should have everything ready to go to start building out code. So if we wanted to, and what we can do, we can look at what it looks like to actually build out a new repo. I'm going to delete the 2023 folder because we don't need that anymore. How do I want to play this? So we can make a new folder if we want that has, like we're going to start working for our prototype code for Flash. We can, or for the prototype robot that has the swerve modules on it and has like our vision testing robot, the thing that we're going to try to start being able to use the 2023 software for. We can go ahead and make a new folder to do that. Something like Flash 2023. Good enough name. Kind of depends on what the project we're doing. and then we should just be able to copy out that Spectrum Robot template that we just made, because all of this has our should be ready to go to be our starting point for any robot that we're going to start programming in the 2023 software. That one's gone. Oh, I already closed the other one. Okay, let me open 2023 again. And open folder. Flash 2023, and so you select the whole folder. It should be able to build. We'll make sure that that's still true. Okay, so it can still build. All right, so things that would have to do. So the biggest thing we're going to have to do to make this actually work, this is actually a little bit easier than I thought. I thought we were going to have to change some of the code, but we didn't have to do too much because most of this was clean enough to where it all stayed without too many updates. So the next big thing is actually trying to move over and getting a kind of cleaner version of our swerve code from last year that we can start templating out for both the prototype robot and for when we redo Infrared 2022, so we can have that code functioning and we can have that robot running on the new stuff already, hopefully. And then eventually, when we go to actually write and start programming the 2023 robot, which won't physically exist until sometime in February, but we want to have everything ready for it and in some way that we're going to be able to maintain nicely throughout the entire season. Figure out if there's any new kind of features we want, things we want to update. So being able to start writing swerve code now that we're able to use next season is pretty beneficial. There are a few differences in the different robots. The 2022 one is going to be very, very similar to the 2023 one. There shouldn't be too much differences there, but between the prototype or Flash and that one, there are some differences. But most of it's going to stay the same, and most of it's just going to be configuration differences. So I'm going to go ahead and open a new window and open our 2022 code, and we can see sort of what the swerve code looks like in there, and what parts of it we need to pull out and how that's going to work. I don't want to import in this case because I'm just going to be looking through things. We can see what files we need to basically copy and how we're going to update things. So the biggest change is in 2022 we didn't have our new sort of by mechanism organization system. So the commands for swerve are in a different place than the swerve subsystem, which is not going to be the case moving forward. Same with some of the config stuff and telemetry. A lot of the things were all over the place last year, and so we're going to try to keep everything a little bit cleaner. But that does require some changes to how we do things. So the swerve folder, we know we're going to need a swerve folder anyway, so we can start with the subsystem swerve folder. So I'm going to copy that over into here, into the robot folder, and paste. Oh wait, there's a problem. I'm going to not do that. Ooh, can I undo that? Let me see if that would work. Yeah, okay. So the problem is folders should be lowercase, but apparently we did a bad job of that last year, and so some of the folders ended up uppercase. So I'm going to make a new folder and name it swerve, and that should be okay. Sometimes it gets mad at you if you have a folder with a capital letter and then make it a lowercase letter. It doesn't always work nicely. because it still thinks it's the lowercase or uppercase one. Let's see if it's reasonable here. Some of this is it's to be expected, so we're going to change it, move. Oh yeah, so it thinks it's uppercase swerve now, which is a problem. Oh yeah, so change packet to robot.swerve, so that's what we want. And then so it has a bunch of other stuff that's all missing, right? So it has all of these commands, constants, like there's a lot of stuff in here that doesn't currently exist in our template code because we haven't pulled it all yet. So we're trying to figure out what actually needs to get moved and then what gets moved in different ways and how some of that's going to work. So some of these things, like what used to be frc.lib, get moved to SpectrumLib, and that should work. So a lot of those we just moved what we had last year as a local library folder. Now it's SpectrumLib, which we're pulling in again through that Gradle file, and it's handled in like a different repo. So that's an easy-ish fix for things like that. So anything that was just .lib, if you change to SpectrumLib, you should get close. Some things moved around. Some things might have to change a little bit. The rest of it, where we have commands, constants, telemetry, a lot of those are part of the bigger overhaul of how we reorganized everything. So a lot of that's going to get redone in different ways. So inside of Swerve, we're going to have a commands folder. And so that's where, instead of having .commands.swerve and having teleop swerve, where we actually have the bit of code where we tell it actually how we drive around the robot, that's not going to be there anymore. That's going to be in the Swerve's own commands folder. So we can go ahead and copy that and start some of that movement over there. So all of these ones that are in this folder get moved over now into here. Some of these are probably a little early, so like Limelight Aim is going to miss a lot of stuff, and we'll have to deal with some of that. Oh, actually, not too bad. Actually, not too bad at all. So that should just be SpectrumLib. Oh, but we got rid of some of those things. Yeah, so that's where things got weird. So some of the logging we're going to redo for part of this year, which is why some of those changed. So it might not work the same way as we want. But we should be able to handle some of those things. Oh yeah, okay. You'll probably have to do Limelight Aim later. That's more of a jump than I want to do right now. We'll copy that back in when we need to. That's more stuff that doesn't exist in here before we can actually get it to work. All right, so a lot of times we're just changing the package, and the little light bulb can let you do that quickly. Places like this where before we're calling gamepads, they now get called in pilot in things, and they're a little bit, we're going to change some of how we do this as well. Oh no, that's actually correct. So they'll be in pilot gamepad. We'll have a get drive X, get drive whatever, and we'll have those methods set up correctly. They'll just be in pilot gamepad now and not gamepads. And like robot has one, so it actually is robot.pilot gamepad, because they're all instances now to clean some things up. Because we had been doing some things that were less than ideal in terms of organization, and a lot of things would just start getting messed up if we had too many people working on it, or if you wrote something just a little bit wrong, it wasn't going to look the way we wanted it to. So now we can do pilot gamepad. What does that now look like? In pilot gamepad. I want to do. So we can see, does it have a configured? Yeah, so it has a configured. So we should be able to do the same thing there. Dot configured. Yeah, so we can basically check if the gamepad is actually configured, go ahead and do the driving things. If there's no controller, just stop. So if we're telling it to run teleop swerve and there's no controller for some reason, there's no pilot controller at all, we're just going to have the robot stop, and so that's what that bit of code does. When it actually is configured, it's pulling everything out and letting us actually drive the robot. We'll look at some of the, we'll have to fix some of these here in just a second. So yeah, so there's no more subsystems anymore, so now this just becomes swerve, and so that solves some of the things in here. And then constants is the other one that we're going to have to pull out separately from this. So we used to have a constants folder that had constants for everything. Now they go in the same folder. So inside of swerve, we will now have the swerve constants, similar to how we have, or sorry, it's actually not constants, it's going to be renamed to config here once I get it a little bit happier. Yeah, so this is going to be renamed to swerve config, because that's actually what it is. So there's some more configuration stuff that goes into it than just being constants. What do we need to pull out? So some of the other things are going to end up being some motor definitions and some other stuff. We're going to try to get rid of all of this, all of the errors in here to where we can eventually get it to build. This is definitely going to take a little bit of time to sort out where everything goes in the new configuration system. It's by no means easy or perfect. Swerve module constants. Oh, so it had that before. I don't remember. That might still be up in SpectrumLib. Maybe not. Okay. It is sometimes helpful to actually have SpectrumLib open. It can be lib or lib. It doesn't really matter. There's a bunch of debate about which one it is. I'm going to open the folder. We already have that pulled down in my GitHub as well. And see what the organization structure of that looks like. No. Gamepads. Oh, so yeah, so swerve module, it's now swerve module config and not swerve module constants, which makes sense. That's actually what we're calling it. Okay, so that got rid of some of the things we needed, but not all of them. So a lot of it is this CAN IDs. Most of those are, we're going to move those into robotconfig.motors, so we know where the motor IDs are without having to have all CAN IDs, because it was less explicit, because there's a lot of other things that are on the CAN bus. The CAN bus is how everything communicates, so the motors and the encoders and the gyro and the PDH and the pneumatics module, like everything pretty much communicates with the CAN bus. So calling that one thing CAN IDs didn't really make sense. So we're changing it a little bit. So now it's .motors, and so we can go into constants, and we can pull out this little bit right here. And this should get us close for what we want. So instead of the example motor ID, we're just going to have drive motor 0, angle motor, all of those. And now in swerve, instead of importing CAN IDs, we're going to do, oh, so I need to get the pigeon ID that's separate. Where do we end up doing that? Oh, it might be in swerve module. Somewhere we attach the correct teleop swerve, but I'm not sure where that is. Oh, it's probably in swerve configs, actually. Yeah, here we go. So these become motors dot out of robot config. And so now that works for all of these. And so now we can get rid of a little bit more of the red. And we're literally just going to go through and figure out how to get rid of all of the red as we figure all of this out and figure out what's still missing. Okay, so that's gone. So swerve module constants. Oh, because this should now be config. And this should also be, yeah, so these should all be config now. There's probably an easier way to replace all of these, but this is fast enough. Similarly, we're going to replace constants with config here. If it'll let me do it this way. Yeah. If you use F2 when you rename, it lets it actually go through and try to replace any of the instances too, so it'll auto rename any place where it's used. So that is very handy when we need to change how we're calling things, what's the name of stuff. Okay, so yeah, so now we have a whole file that doesn't have any red in it, which is good. And then the goal is to get everything to look like that, which will take a little while. So we can pull, oh, so that's swerve drive commands. Yeah, so that's missing a bunch of stuff still. So a lot of times it'll know how to import it. So if it's not sure where to get something, a lot of times it'll know. This doesn't have, we haven't made a robot.swerve yet, so this is always going to be missing some stuff. But some of it has started figuring out. Swerve config cannot be resolved. Import swerve config. There we go. Okay, so it's only missing robot.swerve, so we'll add that in a second to robot, and that'll get fixed itself. So we're getting closer on some of these. We know that's not correct. We know this should just get changed. And that one's ready to go too. So a lot of times it looks really daunting that there's a ton of stuff all over the place. But sometimes it's a lot of just little things got changed that we haven't updated. And then we can go through and fix those and get everything a little bit closer to where we want it to be. All right, cool. I'm just gonna delete that and then we'll get added back in a second. So these also have to become config. This becomes config as well. And that sets us up correctly. There's something else still wrong. Robot is practice. Oh, so this was where we had some things that were a little bit different here. And so this is where we were determining whether we were running on the practice bot or on the comp bot. We're not doing it this exact way anymore. So it shouldn't be a big deal anymore to use this. So it should just be able to pull the angle offset directly because it'll already have established whether it was, which robot we were running on. If we're running on multiple, we have a way using the MAC address of the actual RoboRio for each robot to know which robot it is. And so it'll already be able to assign that offset without us having this code in there, so we don't even need this anymore. And if we end up finding it doesn't work, we'll add something back and we can always come back and look at it. But for now, that's not important. Okay, so now we're closer again on some of these. It has another yellow thing, so this is never used. That's weird. Why is that never used? This value is not used. That seems odd. No, but it definitely wants to be used. It's definitely used. I don't know why it thinks it's not used. That's very odd. Okay, we'll figure that out in just a little bit. Oh, because we're using module config directly there. Let me see why it's not being used. Okay, yeah, it's not being used. That's fine. Okay, if we end up needing to add that back, we can figure that out later, but that's actually not being used, so that's totally okay to get rid of. All right, so where we still have some issues. We still have some issues in teleop swerve. Just that won't exist. Which we can get swerve config from there. Yeah, so get drive, those don't exist yet, so we'll solve those in just a second. And we have some bigger issues in our actual swerve.java class that we can go in and see what's happening. So we're not logging like this anymore. We'll deal with logging later. So we can go ahead and just delete that, and anywhere where it ends up needing us to fix some stuff, we can. Auton has an Auton constants class, which shouldn't be constant, should be config. We're going to go ahead and rename that. I need to fix that in the template to keep everything consistent as much as we can. And so some of these things are currently getting pulled into Swerve, and we're probably going to change this a little bit. So this is one of those places where this may take a little bit more change than I initially thought when I started to do this tonight. But a lot of this might get pulled out of this really big, long Swerve file. This is one of the things we're going to try to not have very often. So this file is really long. It's 341 lines. And the issue with that is we end up having multiple people using it, multiple changes in it. It gets a lot harder to figure out what version is correct, what we need it to do. So quite a bit of this is probably going to get pulled out into other classes. Some of this stuff up here that's only used in Auton might get moved into the Auton folder so that the people working on the autonomous are the ones actually configuring it and able to change those things when they need to, and they're not having to change things inside the Swerve drive file for stuff that's just happening in Auton, because that gets really confusing and leads to problems on the robot. When one person changes something, they don't tell somebody else. Everything just gets a little bit more messy than we want it to. So a lot of that's probably going to get moved. I'm going to probably try to make this work at least for now to try to get it to build. But there are some things that we definitely have to pull around. Where is name coming from? Name cannot be resolved. That's interesting. Okay, we'll figure that out too. Oh, I'm in the wrong one. Okay, let's see how some of that got resolved. So, oh, because name was pulling it from drive. Okay, that's fine. I'm not too worried about that. We'll deal with that later. This just gets used when we are, when the subsystem has a name, it's fine for it just to be Swerve here. It never needs to change. This might get put somewhere in like the config class if we end up needing to change it, but we probably won't. We do need a pigeon ID, which previously was in can IDs in our constants folder, or in our constants class. It's probably going to get moved into something else in robot config, which is fine. Robot config, it's probably just up here with everything else. And so now instead of can ID, it's just, yeah, robot config is fine for this. So now it knows where the pigeon ID is, and we can go and change it easily in our config class. Auto has the same issue where we have some so all of these don't really need to be. Some of these can be auto, some of them might not be. I'm going to go ahead and move them into Swerve for now, and then we'll figure out if we end up pulling a lot of these out. But I'm going to move them into Swerve config Some of them already were in swerve config. It's a little bit weird of how we want to do that. Yeah, that's a little odd. That should be fine. Okay. Okay. So I'm going to go ahead and paste those in. These should already exist in here. Okay, so now in here, these all can become swerve config and let us at least get this to build here shortly. What if that not work? What do you mean? Key theta constants. Oh, there was an extra bit that was built in here. So a lot of this, again, you don't have to know what any of this is doing yet. Just knowing how to kind of solve it is helpful when we have red things and we want to get them less red so it'll actually build. All right, let's see what else is in here. For teleout swerve, that one, all right. Change type get states to swerve module position. Okay, so this one is a little bit weird. So I think this is something that changed with swerve odometry. So this is one where we're gonna have to actually fix something, I think. There's also something else mad. Oh, there's another one that I didn't notice earlier. Okay. All right, so it looks like that's the only error left is actually inside swerve odometry. So I'm gonna go see what changed in here. So there was an update class. There still is. Gyro angle module positions. But it doesn't like this for some reason. Why is this mad? Change types of get state to swerve module positions. Okay, so the method update takes swerve module positions as a array. And so instead we are currently giving it an array of swerve module states, and that's not what it wants apparently. How do we figure that out? The current position of all swerve modules. Please provide the positions in the same order in which you instantiated your swerve drive kinematics, which is fine. This is doing that as well, except it's returning state, and it wants something else. It wants positions. Okay. Okay, so we have to figure out what has a swerve module position now, and how does that exist? Because we didn't have that before. So I think that's something that's changed in here. So swerve module position is now a class that exists somewhere in WPI Lib. I don't believe it existed before, but I'm also not sure how it's different from swerve module state. So we have these like two different things, and I have no idea how they are. Oh, they are. Okay, so state is having a speed in meters per second, and a position has a distance in meters. And otherwise, they are very similar. It looks like. Let's see. So yeah, so just kind of going back and forth. We can also just, if you drag it around, you can eventually make them be side by side. and we can kind of compare the differences directly. And we can see that they're pretty much the same class. They just have a few different things. This swerve module state has a optimize function that this one doesn't. I don't think that changes much of what we're doing. This is the optimize function from, yeah, so that solves some stuff on how we flip it around and things. But I guess it doesn't need that, so it just needs to have position. So we may still be able to get them in a similar way. So the question is, does module.getPosition work the same way? So inside swerve, we have get states. If we copy that out, can I do get positions and have it work the same way? That's what I don't know yet, but we're going to try and see. And then that's probably going to be the end for us tonight, because I think we're coming up on 9 if we're not already there. Yep, so it's 9:03. So if anybody needs to leave, feel free. I'm going to try to figure out if this does work the way we expect it to. Swerve module position into here. Oh, you need to tell it to import swerve module position. And now for each swerve module, we can do module dot. So we can only do get state. So I need to get a position from the module. So let's see what we got. So the swerve module is ours. So we have, this is part of something that we wrote. So this is one of the things that's in our swerve class. So now we have a get state method, and we don't currently have a get position method. So it's something we have to add. So we're going to add a get position method. Position method, swerve module position. All right, so we want a distance in meters and a angle to give it. So we have currently the angle correct. We need to figure out how to get the drive motor to give us its position instead. So we're going to do double position, conversions. All right, so let's look at what this is. So this is a little bit, so these are getting a little bit more in the weeds. Conversion.falcon to MPS is meters per second. So this is how we're getting velocity out of this. So how fast it's going, right? So we have mDriveMotor.get selected sensor velocity, wheel circumference, drive ratio. We need something to be able to get meters out of this, which is definitely different here. So we're going to do mDriveMotor.get selected sensor position. So we're close. And then we can look into here and see Falcon 2 meters. And so we can see what it asks for. So it asks for ticks, circumference, and gear ratio. So we have selected sensor position, which is going to output in ticks, which is kind of what we want, wheel circumference, and drive gear ratio. So that's definitely what we want here. And now we want to make a swerve module position, not a state. And we want to make this a position. All right, so now we've saved that. Now we have get state and get position. We can come back over here, and we should be able to now do get position. And now we have get positions there. So when we come back down to our issues down here, instead of get states, we're now calling get positions. And that should hopefully make us happy, because it looks like the update changed what it does to ask for positions now and not velocity, which is what we was doing. Does that all still seem to make sense? Yes. Okay. So that all seems good. There's a couple. Yellow is fine. Yellow just means there's something like not needed. We can get rid of them sometimes. We don't have to. We still have a couple issues. Most of that being we haven't actually added the swerve into here. So I'm going to add I'm going to add it up here first. Public static swerve. I'm just going to go ahead and call it swerve. Same here, equals, and go ahead and GitHub Copilot filled it out for me so it knows what it was doing there. And so now we have a few more. Okay, so somewhere in here, oh, here we go. So yeah, so we're about to swerve got fixed because now it has it. And so all we're missing now is in Pilot Gamepad, we need to have these three methods, the get drive Y, get drive X, and get drive R for rotation. And those should be pretty easy. Most of them already exist. So here we have get drive throttle, which we don't need because this is swerve. So we're going to change this to get drive Y. We're going to change this to get drive X. Oop, not C, X. And then we're going to go ahead and make a get drive oh, so this is left stick. We want this to be left stick as well, so that they're both on the same stick. That'd be very confusing if they weren't. And then the way we currently control for rotation on most of our storage drives is with the triggers. We could write this in a different way. So this actually auto-wrote what we want for if we were doing it just on the X curve, which I might leave for right now. And then this should be throttle as well. So this would be driving if we had the left stick moving our swerve and the right stick doing rotation, which is how a lot of people drive swerve. We could also change this to use the triggers if we want, which I think we might be able to do with just get, oh, not right stick, gamepad.get trigger. Why is that not? Triggers, there we go. Dot get twist. Yeah, so triggers.get twist gives us the left one minus the right one. So then you can use them as like a single axis. And so this would be our normal way to drive swerve. And we should be able to now, I got rid of, nothing's red over here. And we should be able to hit build and see if it actually builds. It should, I think. And that'll be pretty close to the initial setup for a subsystem that we're like copying over from a previous year. Again, a lot of things are still going to go into making this a lot better. We're going to hopefully not have this 300 and something line swerve class. So a lot of this is going to get pulled out into things that are easier. Swerve currently, yeah, so its set default command is in here and not in its commands file. Like, there's definitely a lot of things to make follow our new sort of organization system, but that's the basic idea. Okay, so that's all I have for tonight. I'm going to stop that recording.